Hey everyone, today I'm going to go over how to test a hull on ANSYS Fluent. First you want to go to the Geometry tab here and go New Discovery Geometry. This is for fluid flow, Fluent with a Fluent meshing. It's on the left side. I'm going to skip, it takes a minute to load. So what you want to do now is import the geometry of whatever you're trying to test. This is going to be a hull. I'm going to make a video tomorrow showing how to test the propeller, but you import your geometry and it should come out here looking something like this. Now what you want to do is make a sketch looking at your hull. Doesn't matter if it's the front or the back, but make a sketch. So you go sketch, and then you have to click the plane. That's important. And then you go rectangle and make sure to hit draw from center. Here, I'm just making a rectangle that encases the entire hull. I aimed for around 2 times the diameter. Bigger is always better, but it's going to take a little bit longer to mesh later on. But so just make a box around the hull. You always hit escape to confirm. And now what we want to do is we want to make it a solid shape, right? So we want to pull it. One important thing here, make sure to click no merge. And now we're making basically this box around the hull. We want it to be, as far as in front of the sub, around 3 times the diameter. So this is like almost 3 meters. So I made it 12 meters, which minus the 3 is around 9. So 3 times the length of the sub. Now we want to do it again, but for the behind the submarine. And this should be around 8 times the length because we care more about what's behind the sub than what's in front of it. So again, no merge. And you can see here I struggle here, but it should be around 24 meters for a 3 meter long sub. Click off, hit escape. And now the next step is, it's basically Boolean. Hide the face so that you have access to click on that, the submarine inside. But now you want to combine. Make sure to hit merge, or get rid of merge when done, or get rid of keep cutter, click merge when done, and hit subtract, okay? Now you want to hit the shape of the big box and then click that little saw, and then you hit the submarine inside of it, okay? That's just basically keeping the outside box but cutting out your shape in the middle. The reason we do this is we want our fluid, which is the big outside box, okay? But we want to cut out the hull so the fluid can just hit the hull, basically, okay? And then you want to save it and go back to your project. This might not be the best way to do it. It's the way that it worked the easiest for me. If you make sure to save it to your device, and then what I've been doing is go into geometry. I reset, so I kind of delete what I just did, and I open, you'll see me here do it in a second. I reset, and then I open the other option. So I open design modeler geometry, okay? After I import what I just did right here, right? And then I open it in design modeler, okay? The reason I do this is because we now have to name the inlet, the outlet, and then all the walls as well as the hull. I struggle with how to do it in the other one, so this is just a quick way to get around it. If you want to figure out how to name it in a different way, feel free. But so make sure you're clicking this little thing that I just hit. It's a selection tool that clicks faces. You want to click your inlet, right click it, and then hit name selection and name it your inlet. And then you do the same for outlet down low. And then always hit generate on this one too. When you import, when you do everything, hit generate. It shows that it confirms it. Now you want to select each of the hull faces, of the wall faces. You have to hold control to select multiple. Name them walls. And then you're going to have to hide a face one more time so you can get access to that little inside guy right there, the hull. And then you want to click that and name it hull. Make sure on the left side here, there's a check mark next to each one of them, and then hit generate after every time. Even when you import for this, you have to hit generate for it to show up, okay? And like I said, there might be a better way to do this, but this is the most simple way that I figured it out. Yeah. Now the next step is going to go into meshing. So we just want to make sure that we're good here. Everything has checks. Save it. Always make sure to save. And then we want to go to meshing, which I should go to in a second. Here we go, hit save, and then you go to meshing. So all we just did there, basically, we made that big box around your submarine, which is like the fluid flow, and then we cut out your submarine. So it's like the fluid is flowing, and then it's hitting the submarine, which is now just like a spot the fluid can't go, if that makes sense. And then we named it all. Now we go to meshing, which meshing is where we define where you define where on the submarine data is being calculated from. I always set it to 6 for solvers if you're on like a school computer, because they can handle a little bit more than like a laptop. It'll just impact how long everything takes. I think I skipped the first step. Make sure to import, just hit the import geometry where there's that check, and then hit import. Now that we're on add local sizing, you say yes. We want to name this local sizing something relating to the hull. If it's something else, like a different control surface, we can name it that. And then for target mesh size, I set to 0.05. All these numbers that I'm going to be adding are rough estimates from things other teams used. Make sure to click hull under label, and then hit add local sizing at the end. But all these numbers, they're just what I've seen other teams use. You can make slight changes to them depending on, information that you gather. There should always be that check. Now we go to generate surface mesh. This is going to be where on the fluid the information is getting gathered from, how often the fluid is going to have like a little sensor almost. So I set minimum to 0.5 and max to 0.5, or minimum to 0.05 and max to 0.5. Make sure to set size function to curve and proximity. The rest of this stuff should be all good automatically. And again, all these things, the numbers can be slightly changed if you start to learn what they mean, and if you want a different result, that's completely fine. I used a lot of chat to help tell me what we're trying to replicate. So I generate the mesh, I cut it. This is going to take a minute, but once it's finished, it should have a check like it does right there. Now for describe geometry, make sure the geometry consists of only fluid regions as well as the other button I clicked. Now here you want to have you want to have walls selected to symmetry, as you can see I go to, as well as have hull selected to wall. It's just showing how the testing is, how the application is defining each part. So now for boundary layers, we do want to add boundary layers. We want it to be smooth transition type. You can name it whatever you'd like. Number of layers I set to 12. That's because a higher number is always going to be better. It's going to give you, more information for your hull. The more you make it, though, the more complex the analysis is going to get. 12 is just a good number that should work well without adding that much time. That should just work. Hit check. Now for generate the volume mesh, we want to go to poly hex core. For peel layers, I put 3. Again, these are just numbers that I looked up. And then for max cell length, I put 0.5. That should be the same max as the other one we used earlier. And then down here, you want to turn yes for avoid 1/8 octree transition, 1 for self proximity, and leave no for the other one. So yes for those two. And then you're at max aspect ratio, you want to put to 50. Again, oh yeah, and your max cell length, you want to set to around 0.1 or 0.08. This is only if the thing you're testing is the same size as mine, and everything's in meters. I don't know if I said that. So it's going to take a while to generate, but once it's done, it should look like this. I think it looks pretty cool. It's just showing you all the little spots that it can move, that it can sense fluid hitting it. So now we want to go to switch to solution. It will also take a while to load. And this is pretty much the final step. Make sure you are on steady, pressure based, and absolute for your general. Do not have gravity checked. Now we want to go to models and go to the vicious. Make sure you're on K omega and SST under the K omega model. And just hit OK. It should automatically do that. Now we want to go to materials. Yeah, and none for turbulent viscosity as well. Now we want to go to materials. We want to add a material. We don't want air, right? So we want to go here and go to our Fluent database and scroll all the way to the bottom and set it to liquid water. All the constants should be good, and we want to hit copy, so that makes a new fluid, okay? So hit copy and then close. This is defining, again, what fluid is moving and hitting the submarine. Now we're going to want to go to cell zone conditions. You'll see they both show up. It's right there. You need to see it like that. Air is still going to be there. That's okay. We go to cell zone condition, like I said, expand Fluent, and then both of these for the example and the fluid beneath it, you need to change the material name to water liquid. Okay, that's very important. That is the fluid that we are testing. Okay. You'll do it for both. Don't mess with any of the other things. At least not for this basic test. This is just to show you how to use the UI. Hopefully you can then go on and learn a little more. So now your boundary conditions. This is for our inlet. We want to set the velocity of the fluid. I set mine to 2.3 meters per second. That's around 5 knots. That's what a lot of teams did. And then for specification method, always intensity and hydraulic diameter. Your turbulent intensity is 0.5. That's a standard number. And then your hydraulic diameter, it's just the diameter of your submarine. So for us, it was 0.6 meters, okay? So 0.5 is a constant, and then the 0.6 is just your hull's diameter. So you need to know that number. Now we don't touch internal. For outlet, we have to go and do the same thing where we go intensity and hull diameter or hydraulic diameter, 0.5 and 0.6, okay? Don't touch pressure or any of the other stuff. It should be all good, okay? Now we want to go to symmetry. Make sure walls shows up under symmetry. That's the step we did earlier. And then for hull, I'm going to do this incorrectly, but I'm going to fix it after, all right? Roughness constant, make sure to leave it as 0.5. Do not change it to 0 like I am right here, okay? I'm going to fix it in a minute, but do not change that number, okay? I changed it right there, right? Don't do the first thing I just did. Leave it at 0, okay? Now for reference values, this area is just pi r squared. So my diameter was, like I said, 0.6, so that's 0.3 squared. Set your length of your sub, set your velocity, and then nothing for reference zone. You want your compute from at the top to be your inlet, okay? So compute from, I'm going to click inlet. And like I said, the area is just your pi times your radius squared, okay? Now we want to open methods. Make sure it's on simple. Not simple C, simple, just like that. And then confirm that as well. Now monitors, this is showing us, this is going to show us our report basically, okay? I opened report definitions. I had to delete these because I went through a test earlier, so you won't have that. It'll look like this right now. You go new, force report, drag, and then you want to do one for drag coefficient and one for drag force. So I'd name it, drag coefficient hull or whatever. You click the hull, not hull shadow, and this is important, your force vector, okay? If you look at my image, the fluid is moving in the negative y direction, okay? So I set it to -1. If it's moving in the positive x direction, you set x to 1 and everything else is 0. It's just in the direction that the fluid's moving. So I did one for drag coefficient. Now I'm doing the second one for drag force. Everything's the same. It's just changing how it's showing your fluid moving. So -1, x is 0 because the fluid's only moving in the negative y direction, okay? This is what's going to show up after you finish your test. It's going to be where your information is, and you should see it under report definitions right there. Now you go to initialize, make sure it's under hybrid initialization and hit initialize. It'll take a while to define. And then number of iterations, I think 500 is a safe number. You can do as high as 1,000. It's just going to take a while, okay? Now you hit calculate. I did a very quick time lapse. This took probably 15 minutes, but this is just going through iterations and running the test. You want it to be a steady line like that. No changes, okay? And then when it's all done, you're gonna get something like this, and you can fidget around. Contours is where you can pull up the image where it shows the different effects of things like pressure or velocity of fluid, and it'll appear here. And then once you're here, you can just look around. You can check out all the different information and you know, hopefully make changes to your CAD model and to your test. So I hope this is helpful. I'm here for questions, and I appreciate you guys listening.